So based off our answers in question number 7, we are asked to find the pH of a solution that has a pOH of 4.6. So with having the knowledge that adding the pH and pOH together that equals 14, one must only subtract 14 minus the pOH. So 14 minus 4.6 will give you a pH of 9.4. Also, we learned that the multiplication of the concentration of H plus and OH minus will give you 1.4 times 10 negative 14. So when we're given the concentration of H3O plus is 2.55 times 10 negative 3, and to find the concentration of OH minus, all one must have to do is divide 1.0 times 10 negative 14 by the concentration, so 2.55 times 10 negative third, to give us 3.92 times 10 to the negative 12 molarity. Question number 9 asks us what is the pOH of a solution that has a concentration of H plus equal to 4.22 times 10 to the negative 3 molarity. So do the same thing as we did earlier. Take 1.0 times 10 negative 14 divided by 4.22 times 10 negative third, which will give you a concentration of 2.4 times 10 negative 12 molarity. Then take that and plug it into the equation, the negative log of the concentration of H plus. So then you have the negative log of that concentration, 2.4 times 10 negative 12, and you will get a pOH equal to 11.625. Number 10, it says that a certain solution has a pH of 3.25. So first, it asks to find the pOH of the solution. So all one must do is subtract 14 minus that 3.25 to get a pOH of 10.75. Then it says find the concentration of H plus of the solution. So then just take 10 to the negative 3.25, and you can get the concentration to be 5.623 times 10 to the negative 4 molarity. And then it asks to find the concentration of OH minus of the solution. So then just take that 10.75 that we solved for earlier and do 10 to the negative 10.75, and you can get a 1.778 times 10 to the negative 11 molarity. This next question asks to find the pH of a 0.035 molarity solution of HNO3, or nitric acid. The hint tells us that nitric acid completely dissociates into H plus and NO3 minus ions. Therefore, we know that the concentration of that H plus will also be 0.0035 molarity. So then just do the negative log of 0.035 and you get a pH of 1.46. Then it asks to find the pH of a 0.16 molarity solution of HCl. We also know that HCl fully dissociates because it is a strong acid into H plus and Cl minus ions. So then just take that 0.16 molarity concentration, plug it in that formula, negative log of 0.16, and you get a pH of 0.80. Then it says find the pH of a 0.045 molarity solution of NaOH. Since NaOH is a strong base, it will fully dissociate into Na plus and OH minus ions. First, find the pOH by taking the negative log of 0.045, and you'll get a pOH of 1.35. But it wants the pH of the solution, so one must subtract that 14 minus what we got for our pOH, 1.35, and you get a pH of 12.65.